Welcome, everyone. Today we are diving into the ultimate evaluation of a prompt engineer, the Advanced Mastery Checklist. We are going to explore how to handle complex, multi-step engineering prompts completely unassisted. Let's get started. Let's set the stage. The Advanced Mastery Checklist is not about learning basic chat commands. It evaluates your ability to handle complex, multi-step engineering prompts completely on your own. When we build advanced AI systems, ad hoc prompting simply breaks down. It leads to context-rot and unpredictable behavior. To achieve mastery, you must shift your mindset. You are no longer just an instruction giver. You are a cognitive architect. You engineer the exact environment, boundaries, and logic the AI uses to solve problems. By mastering the core pillars of recursive thinking, metaprompting, and constraint engineering, you transition from a regular user to a power user capable of orchestrating highly autonomous AI workflows. Take a look at this progression timeline. We all start at basic prompting, moving into intermediate context management. But the green node advanced mastery is our goal today. Reaching this level unlocks three critical pathways: recursive thinking, metaprompting, and constraint engineering. These are the foundational pillars you must demonstrate to pass the mastery checklist. The first major criteria on your mastery checklist is recursive thinking. This isn't your standard think step-by-step arithmetic. Recursive thinking builds layers of analysis where the AI actively challenges its own assumptions. Imagine asking Claude for a strategic business plan. Instead of taking its first answer, a master prompt engineers a self-questioning cascade. You instruct Claude, generate a solution. Now, challenge three assumptions from that solution. Finally, integrate those challenges into a refined recommendation. It forces the model to play devil's advocate against its own logic. However, you must engineer human validation gates into your prompt. If a logical flaw occurs at level 1, recursive thinking will amplify that error down the chain. Mastery means knowing how to catch it. Here we see the recursive architecture. We move from level 1, identifying the core issue, down to level 2 where we challenge assumptions, and level 3 where we synthesize. But notice the critical yellow decision diamond, the quality check. A master prompt always pauses the cascade here. If the logic fails, we loop back. If it passes, we safely proceed to analyzing second-order effects. Checklist item number 2 is metaprompting. This is the prompt evolution engine. A novice tries to write the perfect prompt from a blank page. A master asks the AI to construct the optimal instructions. You create a feedback loop where the AI systematically refines the conversation. For example, you instruct Claude, "Here is my goal. Tell me the 5 best questions I should ask you to achieve this." Answer the first one, and use that insight to rewrite the remaining 4. You are using the AI to dynamically adjust your strategic roadmap. But the advanced mastery test requires strict parameters. You must define objective success metrics like a 1 to 10 clarity scale, so the AI has a mathematical baseline to optimize against. You are building an engine that improves itself. This state diagram maps out the prompt evolution engine. We start with a draft prompt and execute it. The output immediately flows into an AI evaluation phase, rated against objective criteria. The AI identifies weaknesses, generating a refined prompt, which loops right back into execution. This continuous cycle only stops when your strict success criteria are perfectly met. Our third mastery evaluation is constraint engineering. Large language models naturally want to take the path of least resistance, giving you generic, corporate fluff. We fix this by introducing productive friction. By banning high-probability buzzwords or imposing impossible limitations like solve this market entry with zero budget and a 24-hour deadline, you mathematically force the model into its deeper latent space to find novel solutions. A master prompt engineer uses cascading constraints. You ask Claude to explain a concept in 500 words, then 100 words, then a single sentence, and finally one metaphor. The insight that survives this relentless funnel is your unbreakable core concept. Just remember, always validate the feasibility of these lateral ideas in the real world. Visualize the cascading constraint system as a funnel. The raw idea enters pass 1 at 500 words. As it travels downward through pass 2 and pass 3, the limitations become incredibly aggressive. By the time it is squeezed through pass 4 into a single metaphor, all the fluff is destroyed, leaving you with a bulletproof, highly refined core insight at the bottom. True mastery isn't just manipulating text, it's orchestrating complex systems. The checklist requires you to handle tool and context orchestration flawlessly. This means writing prompts that coordinate Model Context Protocol, or MCP, tools alongside isolated subagents. When building long-horizon workflows, you don't just ask Claude for code. You construct a master supervisor prompt that dictates exactly when to use a tool, when to spawn a subagent for isolated research, and when to bring that data back to the main thread. A major part of this evaluation is defeating context rot. A master knows that dumping massive tool payloads into the chat history will break the model. You must proactively instruct your prompt to compact and summarize its own memory state to keep the context window pristine. This diagram displays proper architectural orchestration. The supervisor prompt sits on the left, maintaining clean context. It delegates heavy lifting to a research subagent and a writing subagent. These subagents utilize MCP tools to access a vector database and the file system. Crucially, notice the dotted return lines. The subagents do not return massive, messy logs. They return clean summaries and saved files back to the supervisor. The most difficult item on the mastery checklist is the decision framework. Anyone can copy-paste a massive, complex prompt. A master knows exactly when to deploy it. If you use recursive chain of thought for a simple formatting request, you are wasting tokens, bandwidth, and money. If you under-engineer a high-stakes data migration, you invite catastrophic failure. You must assess the complexity, the required accuracy, and the token budget before you type a single word. Furthermore, the checklist evaluates your ability to recognize failure modes in real time. If you see the AI's reasoning becoming circular or artificial, you must realize your metaprompting loop has stagnated. A master knows how to immediately break the loop, flush the context, and pivot to a more effective technique. This decision tree represents the master's mindset. We begin at problem assessment and hit the complexity level diamond. If the task is layered and high stakes, we route to recursive thinking. If we need process evolution, we use metaprompting. If we hit a creative block, we route to constraint engineering. And if it's just quick execution, we swallow our pride and use standard prompting. Let's put this into a real-time use case, the enterprise system pivot. A senior engineer must evaluate migrating a massive monolithic application to microservices. A novice prompt will just give generic pros and cons. A master engineer deploys a synthesized super prompt. Part 1 initiates recursive thinking to dig into the hidden layers of technical debt. Part 2 injects an impossible constraint, asking Claude, how would we accomplish this migration if we had literally zero budget? Part 3 orchestrates subagents via MCP tools to actually read the local codebase and validate the theory. The outcome is magical. The system returns a validated, hyper-specific architectural roadmap that highlights a hidden vulnerability in the authentication flow. This is what it means to pass the advanced mastery checklist, synthesizing multiple complex frameworks into a single, flawless execution. Look at the sequence of this master execution. The engineer sends the synthesized master prompt to the Claude supervisor. The supervisor first executes internal recursive analysis. It then reaches out to the codebase MCP to validate its theories against real constraints. The MCP returns the metrics. The supervisor meta-evaluates those findings internally and finally returns a bulletproof, validated architectural roadmap to the engineer. To conclude, let's review your final advanced mastery checklist. You must prove you can master recursive thinking by layering analysis with strict validation gates. You must optimize metaprompting by building self-evolving prompts based on objective math. You must break through constraints to force lateral, out-of-the-box solutions. And most importantly, you must demonstrate strategic integration, knowing exactly which technique to use, orchestrating your subagents and MCP tools seamlessly while managing your context window. Passing this checklist means you have evolved from a passive AI consumer into a highly systematic cognitive architect. Thank you for joining this masterclass. I invite learners to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. See you in the next session. Our final diagram breaks down the complete mastery checklist. From the root, you must conquer recursive thinking through self-questioning. You must conquer metaprompting via prompt evolution. You must conquer constraint engineering with cascading limits. And finally, you tie it all together with strategic integration and tool orchestration. Master these nodes, and you master AI.